Hello everybody, my name is Ufol and welcome to my brand new channel. I'm currently playing Stationeers and I wanted to show you a couple of ways how you can set up a solar farm. So the most basic one is by using a console. You can use it like that, put the circuit board inside, cover that with glass. You can make all of that in electronic printer, put the data disk, switch it on, and now you can choose all the solar panels that you have connected. Once you do that, take out the disk, boom, and you're ready. It is already generating some power. The sun is getting outside of the view. You can control the rotation and tilt. Let's see how that do it. And you can see all three are working together. You don't need to have wrench in your hand and adjust manually each of them. So that's pretty much it. It's quite handy early on before you have resources to do anything bigger like that. So let's move on to the next one. So the second example of solar tracking is simple one axis. This one is using vertical tilt, and as you can see it's not quite good, not quite aligned to the sun. It can be useful early on, especially on worlds like Moon or Mars, where the sun is traveling pretty much straight up. And on other worlds, you may want to try using the horizontal instead. And I'm gonna show you how this works in a second. So the most important part is obviously the daylight sensor. And this one is positioned this way for a reason. So how does it function? Basically is on default, it's functioning in vertical mode. That means that it is detecting the angle at which sun is shining on the surface that is mounted on. I can show you. Yeah. So basically, it's gonna be this this surface here, and 0 degrees means the sun is shining straight at it. 90 degrees is way on the side, and anything beyond that is gonna be behind the sensor. Not quite realistically, but in this game the sensor can detect the sun shining on the back. So we can just take that to our advantage, and as you can see the angle is rising, and if you place the sensor facing straight to the east, it's gonna show 0 degrees at sunrise and 180 at sunset. And this is pretty much all the angles that you're gonna need for rotating the solar panels. So the next part is a logic reader. You just need to set the input as a daylight sensor, and the variable is solar angle. As you can see, it's still showing that. One funny thing about daylight sensor is that they won't show you their value during the night, but the logic system is still going to detect that. And okay, after logic reader, the one thing you need is a math unit with divide function. So you need to provide it with data from logic reader, that means solar angle, and divide it by 1.8. You can use memory for that, connect it to the second input, and that gives you the output in percent instead of degrees, because solar panels needs percent. And of course the sun is setting. Before I showed you even half of the scene. So we are in daylight again, and I can show you how you can change the axis that the solar panel are tracking the sun. So it's very easy in this case. What we're gonna need is to change this math unit to add and memory to like 90 degrees. Let's click a couple of times. And on the batch writer, we just need to change the vertical and horizontal. And yeah, I messed up something. Of course. Why should it do like it's supposed to? As you can see, the vertical is 130 because there was error during the override. I can quickly correct that. Let's set it at 50%. Yep, it's done. And not quite. Let's do 25. If you press C, you can turn them in smaller increments. Okay, let's see how is it doing. Yeah, right on the target. Of course, it's lacking the vertical. But on the worlds like Vulcan, for example, the sun is traveling very low on the horizon, and you can easily get by just using the horizontal axis. That's obviously way easier and faster to set up than monstrosity like this one. So let's take a look at the next example. This setup is tracking sun in both direction, vertical and horizontal, and it may look a bit confusing at first, but it's pretty simple once you learn how does it work. So it is divided in 3 segments. This one is responsible for horizontal tracking, this part is for vertical, and that little piece is used to reset the panels during nighttime. So let's start with sensors. There's a little change here. The first one is like the others, set up to vertical tracking. This one have to be facing straight up, and the second one is in a horizontal mode. To do that, you can easily use a logic reader and any memory. I can show you an example right here. There's in this case it's batch writer. As an input it takes memory. This one have 1, and output is sensor, and it changes mode, and the mode is horizontal or vertical. So once you have 2 sensors for each direction, we need to set up logic for the signal. So the first logic reader, obviously, And next one is that math unit that takes the signal from reader, and the second input is invert. Because I forgot to tell you, the horizontal sensor gives the opposite angle to what panels actually need. Because panels have a 0 to 360 clockwise, and the sensor is quite different. It has 0 on that flat end and 180 on the end with the cable. Keep getting stuck there. But on the clockwise, it goes on the negative from 0 to minus 90 and so on. On the other side, however, doesn't go to 360, it goes on the positive numbers. So it's only 0 to 180, whichever side you pick. So in this case, we need to invert that angle from minus to positive. So that's what this unit does. It uses that memory with simple -1 and multiply. That changes the sign. The next one, we need to apply offset, because it's usually that the panel is facing the wrong side. It doesn't really match with the sensor. So we need to compensate for that rotation. In this case, it's just 90 degrees. It can be 180, 270, or just 0 if you set it right. So this one is just adding the result from that math unit and that 90 degrees. Once you have that done, you can put that to the batch reader and set up solar panel and horizontal. And that works pretty well. The second part is vertical. So again, logic reader is vertical angle, and this place gets a bit tricky. So I had to look up on the internet. Honestly, I'm not gonna lie. So the idea behind that is to convert that 0 to 90 degrees angle to something usable for the panels. So we will have to use 0 to 50% tilt, because 0 is like flat and 50 degrees, 50% is straight up. We won't do the 100% because it's gonna face in the opposite side. So another thing is that as you can see, this panel doesn't go quite to the bottom. There's always a bit an angle. It's about 15 degrees. So we have to compensate for that. Otherwise, during the sunset, there's gonna be like mismatch and the efficiency gonna drop. So these two logic units are used to multiply that angle by 1.5 and then add 50. After that, just follow to the batch reader again, and as you can see, our nighttime reset just kicked in. So what I just do, I have another logic reader hooked up to that logic sensor, daylight sensor, but it reads an activate state. Activate is whether daylight sensor can see the sun or not. You just need to remember that the sensor have to be in plain sunlight, because if there's any shadow, it will also return 0, and that's gonna be a false positive. So if you want to have it like that, it have to be in direct sunlight. So Next step is that select unit. So this one is gonna act depending on what signal is coming from that one. If it's 0 like that, this one, you can see a little 0 here, will read the memory offset that we had before for horizontal. If it's 1, it will actually read that adjusted actual angle for those panels. So instead of directing the results right from this unit, the batch writer, you can put it to direct it to input for the select unit and then to batch writer. This way, that little box can switch between day and night, and you will always have panels facing east during the nighttime. So even if you run out of power during the night, panels will still be oriented the right way, and you're gonna have some energy in the morning. And let's take a look at the next example. So this one is using a programmable chip, and yeah, it's right here. So to use that, first you're gonna need the circuit housing. Put that chip in there, and make sure that housing is all wired up to the same network as the computer. You're gonna need a motherboard, IC editor inside that computer. Switch it on. I already have a program loaded. You can see it on the screen. Here you can choose the housing that you want to use. In this case we only have one, but if you have more, they're gonna show up here. Make sure you pick up the right one, and now click edit. So this is the whole script. What it does is pretty much the same thing as we did here, only in just one single chip. So you don't need to write that all by yourself. You can just take library, and from library there's gonna be scripts that you subscribed on Steam with that icon, and just use that icon. It's gonna show you a little warning, overwrite that, and you're ready to go. Just confirm, and now the program is in the memory of the computer. And in order to load the chip, just put export. And now you can see on the bottom here, it reads 6070 something bytes. So that generally means that something is loaded to the memory. And now you can take that chip and put it to the actual socket that we want it to operate on. We don't need that computer anymore. And what it does, this script have a couple of inputs here. There's only 3 on the left side, so we need 3 devices here. One of them is daylight sensor, obviously, and 2 others are 2 batch writers, one for each axis, horizontal and vertical. So each pin, after you put the chip in the socket, there should be like on that yellow font, there should be name highlighted for each device. And this one is daylight sensor, batch writer vertical, batch writer horizontal. Just pick them from the list like any other, and the script should work. If it doesn't show you the names, you can switch it on and off again, and it should update itself. And that's it. Well, it's not that easy. I'm gonna explain you how the script does work actually. So now you can see the batch writers are off, and that's not a problem. That's how it's supposed to work. The script needs at least 1 day to update and correctly read the position. And it's pretty much trying to save power during the night, unlike this thing. Because as you can see, all these chips use like 180 watts energy all night long. This one, just 50 for this one. So it's like less than 1/3 of total consumption of this part. And it only updates every couple of seconds. I can show you here. Calculate night sleep. Yeah, so every 10 seconds it's gonna check if that daylight sensor is active. If not, it will come back here. And every 10 seconds it's gonna check. Once it detects it's daylight, it will start going from the start. So first, yeah, get angles. It just pick up every angle, horizontal, vertical. If you want to take a closer look, you can subscribe to that script and read through the code. I provided the comments in pretty much every single line, so I hope it's clear enough to understand. Yeah, next is set the panels, calculation of vertical and horizontal angles. As you can see, that's the operation that we did before, minus 1.5, dividing angle, then adding 50. That little line, it's preventing the panel to go below 0, because if that happens, they're gonna freak out and start rotating and resetting themselves. It's pretty much annoying. And yeah, that's the whole script. Yeah, and half of it is just the comments. So I hope you'll find that useful. Now you can see the script activated. Yeah, it will. What we'll do, you can see the output here. You can see it changing from like 3 point something to 283. That's the two outputs, two angles that it's directing to both of the writers. And you might wonder why there's only one sensor when we needed two of them. If you can see, the mode is blinking for a moment. That's because the chip is changing mode of that sensor, reads quickly the vertical angle, then changing it back to horizontal, reads the second angle, and then calculate the correct position of the solar panels and switch on the writer, put the data in, switch it off, do the same with the other one, and run. This means that it pretty much halves the power intake from the batch writers, reducing the power needed even less. And that's it. I might have, yeah, one important thing. As you can see, the panels are facing the wrong side, so we just need to correct that one line. That's the That's the only thing you may want to change in this script, just that horizontal offset, the same that was in the other one with memory. Let's confirm. Let's take that chip, update it, put it back, and yeah, 99%. You cannot get more. So I hope you're gonna find this tutorial helpful and you're gonna be able to set up some quick solar farms yourself without the help of the wiki all the time. So that's it. And on that note, I want to thank you for watching. If you enjoyed the video, please press like and subscribe. Have a nice day and see you next time. Ufol out.